These are a series of videos for the Chapter 1 PowerPoint presentation from our old textbook. And the book's kind of old, so we're going to discontinue using it. But some of the information is still pertinent for the class, so I want to present it here in a short little video. These are optional. It's just information that every programmer should know. And this first part is talking about hardware and software. All right, and most of you all know that hardware is the physical component and software are the programs that you write. But it's really important to know how the two of them interact. And so with the hardware, we have what is called the central processing unit. That's really the brain of the computer. It's what carries out all the commands. It's what tells the rest of the computer what to do. And so the central processing unit is the processor itself in the computer. We sometimes call that the microprocessor. And then there's the main memory. And the main memory is where we store information that's being processed on the computer. So it really takes both of these. You have to have a good processor and you want to have lots of memory. All right? And it's a combination of those two that make a really good, fast computer. And the CPU, like I said, we call it a microprocessor. Its main job is it just performs a certain cycle of instructions over and over. It fetches the instruction, it decodes the instruction, it executes it. And it fetches, decode, and execute. And it does this over and over again as fast as it can. All right, and it's going around. And so the clock speed that we set, which is kind of a metronome, it just sets the speed of all the functioning on the motherboard. But the clock speed of the processor is something that you want to look for, is how fast is the processor, how fast can it perform these operations. And inside the CPU, you basically have three different parts, and you'll hear about these: the arithmetic logic unit. That's what's actually performing the math. And then the logic is the comparisons, like if this one's the same as that one, or this one's greater, or this one's less. All right, those comparisons are all done by the logic unit. The control unit is kind of the general in charge of where the instructions are being passed around. The registers are small little memory locations where we can place things on the register. We can get and put things. And if you ever get into assembly language, you'll learn to work with the registers on the CPU. And it's different for every computer system. As I mentioned, the speed of the CPU is controlled by the system clock. And it's that clock speed that you see. And sometimes, the page here talks about megahertz. Well, megahertz is kind of old and slow. We really measure things in gigahertz. So you'll hear about a processor that maybe is like a 3.2 gigahertz processor, or maybe a little bit faster. But it doesn't get too much faster because we've kind of reached a limit on how fast our current processors can go. So what they're doing now is putting multiple cores or multiple processors all on one. So you'll hear about a quad core processor. That means it's a processor that has 4 cores, which is very similar to a locomotive going down the train tracks. Well, it can only go so fast, but if you put 4 locomotives on the train, you can do a lot more. You can pull a lot more train cars. And so that's similar situation with the processor. If I have 4 processors and they're all working at the same time, I can process more data. And that makes it faster. Okay, and then the main memory. All right, we talk about main memory on the computer, and the main memory is volatile. All right, and the word volatile basically means if you shut the power off, it's going to go away. It'll be lost. All right, but then you have non-volatile memory, and that's where you save things, say, to a hard drive, and that way it's stored. And it's stored often magnetically, so that when you turn it back on, it's still there magnetically, and you didn't lose anything. But the two are different. So yeah, the main memory, which is on the motherboard, and then you have the secondary memory, which is some kind of device. And a lot of people nowadays, they use the internet as their secondary memory, but it's still being stored somewhere so that you can access it. It's a similar thing. And we call about direct access, or we call that random access. And random access allows us to go from the front, the beginning, the middle, wherever we want to go. We can just go directly to the information. So we have 2 types of RAM and ROM memory. The RAM memory is that volatile direct access memory. That's the information that we use while we're running the computer. For example, right now I'm talking on my computer. Right? information, my voice is being recorded on the RAM memory. It's not until I save it to the hard drive will I be saving it to a secondary non-volatile memory location. Now, ROM memory is not that secondary location. ROM memory is like a book. All right, it's like a textbook that has text on the pages, and you can't erase the text. You can't change the text. All right, and so that ROM memory is really handy when you turn your computer on, for example, and it does the same instructions over and over again. All right, because it's been recorded on chips, and so when the computer comes on, it starts up and it runs over and over again. Okay, so ROM memory is called read-only memory. RAM is random access memory. There's a lot of different types, but as long as you understand the concept of memory in the computer, you're in good shape. All right, and then here we talk about other secondary devices that you can store it. Anymore these days, I haven't seen a floppy disk in years, other than in the bottom of my file cabinet. But most people these days store things on hard disks. You might still store things on a flash drive. You might still store things on a CD. Rare and rare. A lot of computers don't even come with CD players anymore. All right, but you'll store things on the internet, all right, and on the cloud, and that means it's being stored online on some company's storage device that you can access. All right, and of course, in the computer system has different input and output devices. The primary input device is still a keyboard. You know, they've promised us years and years ago that we were going to be talking to our computers, and to a certain extent, we can give voice commands to our computers, and they understand it. But for the most part, we still need to use the keyboard for a lot of what we do. All right, so typing skills are important. And then, of course, we have our primary output device, which is a monitor. But there's lots of other output devices. There's speakers, there's printers. You can think of a lot of different types of input and output devices on the computer. And then finally, there are different types of software. All right, and the first type of software is called the operating system. The operating system is the Windows of the world, the Linux of the world. It's the Android system or the Apple Mac OS systems that are out there. And we don't really use the operating system very much. Instead, what the operating system does is it is used to as an in-between between the applications, the programs that we run, and the hardware. Okay, how does the application save a file? Well, the operating system actually does that. The application sends the file to the operating system. The operating system then takes it and saves it to the hardware. Okay, so the operating system is really important, and that's why we have some major operating systems out there, and they're all kind of battling for dominance. On the desktop computer and laptops, it's still primarily a Windows world out there, but there are other ones making inroads. The Apple is real big on the iPhone system, their cell phones, and of course then you have the Samsung and the Android system that are out there that run the different computer devices. Now the applications are all the different programs, and we're going to write little mini applications in this class. But bottom line is you need to have that operating system to make it work. Now it does talk about the graphical user interface. We're not going to be doing that in this class, so you don't have to worry too much about the GUI system. In this class we'll be writing just basic text because there's a whole nother layer of complexity when you want to start doing things for graphics.